Hello everyone. So this is the task 2 of the internship program. The task 2 is the prediction using unsupervised machine learning model. In this method, I have used a k-means clustering algorithm. So what is a clustering algorithm? A clustering algorithm is an unsupervised way where there is no such specific way from which the model can learn. The model learns by itself. In this way, clustering is the method of making into groups from the entire dataset. As you can see in the image, there are few datasets which are in the green color in the entire XY plane. Then after making into clusters, they have formed into different groups. The one is the green one, the blue one, and the black one. So this clustering, how can we get to know that which is the right number of clusters required for a particular dataset? So for this, there is something called as elbow point. Firstly, we need to make a plot on the x-axis the number of clusters and on the y-axis the average depressions. While looking at the graph suddenly changes from dropping to downwards to moving horizontally forward. So this is the point where we can see it makes like an arm, and that particular point where this sudden change occurs is the point 3, and this point 3 gives us that this is the satisfied, or we can say appropriate number of clusters for this particular data set, and this particular point is called as the elbow point. Then is the centroid thing. Now what is the centroid? Like this clustering, the k-means cluster works in the mechanism like in the entire data set. It makes if I am making a two clusters as two, then it will take as two inputs, it will assign two different weights, two different average weights, and based on those two different average weights, it will calculate the distance, Euclidean distance, between all other points, and the points which are nearer to them, it will assign that data set to that particular centroid value. So the particular value which are near to all those different values, that particular first value is called as the centroid. If you're making two clusters, it will be having two centroids. If you're making three clusters, we'll be having three centroids. Okay, then this is the way how mechanism, like how clustering works. First, earlier it was completely mixed up like this, and then after that you can see the blue color and the red color and the green color. There are the three different clusters drawn in the XY plot. So after this, we'll see how this clustering, k-means clustering works. We'll directly jump into the Google Colab and see the mechanism of this particular k-means clustering algorithm. Okay, so this is a Colab notebook, and this will see how the k-means clustering is being implemented. So firstly, we'll connect our Python by clicking over here. So it's connecting. So then we'll see what are the packages we are importing. Import pandas as PD for the importing of data. Sklearn.cluster for k-means clustering algorithm. Sklearn.preprocessing for min-max scaler. Min-max scaler is used for um, to make a x and y plot properly, so that all the proper points are arranged in a sequential manner, and the matplotlib.pyplot for scatter plots. The Python has been connected, as you can see a green tick over here. So first we'll run this cell. It's running okay. Then after this, we'll import the data from this particular path. This is the iris data. Iris data is the petal and the flower sepal data. Based on those data, we'll make clusters of different, um, like the cluster of sepal and cluster of petal. But with this, we come to know that yeah, there are different two, sepal is one thing and petal is one thing. Yeah, if we can easily differentiate both of them. But for a data set which we are having a large, more number of columns and more data set, it's like difficult to get the right number of clusters to make them. So firstly, we'll import the data and print the number of 5 rows. Then after that, we'll first scatter plot them. So I'll run this. Okay, then this is the scatter plot where we'll be plotting the petal length and the petal width on the x and y axis, and we'll see, okay, this is the total number of data samples in the xy manner. Now we have to make the clustering over this particular data set. So firstly, we'll make the min-max scaler so as to scale the x and y axis properly, As you can see there, this is 1 2 3 4 5 6 7 and zero point 0.1 0.5 1. So as to make them properly between 0 to 1, we are using the min max scalar. So we have make a scalar variable which is the min max scalar class, then scalar dot fit the petal length which will be on the x-axis. So we'll transform the data. Transform will the scalar dot transform is the particular method for transforming that entire dataset between zeros and ones, and then again assigned to the data column of the petal length. The same will be doing with the width column. Scalar dot fit of the petal width and scalar dot transform of petal width to the petal width variable itself. Then we'll finally display the data again. So we'll see the petal length as 0 0.06, 0 0.06, 0 0.8, 0 0.1. Then over here is the petal dot width is the 0 0.13, 0 0.13. So everything is going to between 1 and -1. Now elbow point. Now to see the maximum number of the right number of clusters required for this particular data set, firstly we'll make a list over here and we'll iterate that thing and make into plots of a graph so that to get the right number of clusters. As you can see, this is the final outcome. This is the square mean error 02468, and based on those square mean error, which should be the right number of clusters, we have the cluster values as 1 2 3 4 5 6 7 8. Then as you can see, this graph is going like this, and suddenly at the point of 2 it's changing its path. Yeah, even it's changing its path at 3 also, but 2 is the right number of clusters to be formed in this particular data set, as there is a huge variation at point 2. So 2 is the right way of clustering, right number of cluster. So I'll just run what all missed from here and this. Okay, yeah, this variable issue. Okay, scalar. Okay, then the elbow point will run this and see there what is the right number of cluster. Yeah, okay, 2 is the right number of cluster. We'll be taking k is equal to 2 as the appropriate number of clusters. For clustering, we'll first use the k-means, and n cluster is equal to 2. We'll pass this variable as 2, and this entire model is in the variable called as model. Then petal underscore model is the prediction value model dot fit of petal length and petal width. Then if finally display the petal model, then this ensures that the model has been successfully implemented on this particular data set. Then petal underscore predicted gives the predicted value of the petal length and petal width. As we can see, these have entire cluster formed, like 1111 is the cluster and 000 is another cluster, like which particular length in the entire length and in the entire width, which should be considered as cluster 1 and which should be considered as cluster 2. This is the entire array. Then we'll see this variable model dot cluster underscore centers is the centroids values, like the centroid values which are the mean centers, and from those centers we are calculating the Euclidean distance. So this is the cluster underscore centers. With this variable we can see the centroids of this particular data set. Then after this we will see the clusters. We'll make a cluster variable, and we'll like what was the cluster we got over here. This is the value of the cluster, zeros and ones will again assign to a particular column, and that column will be adding to our data set. So this is the petal underscore predicted value, and will assign to a data in our data set with the column name as cluster. And data dot head, we can see that this is the petal length, petal width, and this is the corresponding cluster assigned to it. Now finally, the last step is the just to print the just to get the scatter plot and to finally get the clusters. So for this we'll be making two clusters. If data df1 is equal to where the cluster value is 0 and df2 where the cluster value is 1. So in the first we'll was scatter plot. We'll perform the petal length where we have the label as petal length and the color will assign as red, and the another is the data set 2 which is in another cluster. We'll assign to this as green color, and then we'll finally clear to the scatter will be having the moderate cluster centers. Basically this line will give just the centroid values, which will be assigning color as black and the label as centroid. So as you can see over here, the red color is the petal length, the green is the petal okay, just I haven't changed the variable. This should be the petal width. Okay, yeah, this is the petal length, this should be petal width, and this is the centroid values. Okay, so this should be petal width. Yeah, okay. So after this we'll be getting the petal width and the centroid values. Let me run all those things again. Yeah, okay, this has been done. Okay, now we'll see the final outcome. Okay, yeah, this is the petal length, this is the petal width, and this is the centroid values, black spot over here and here. So with this we can see that there are two clusters formed. The petal width is the green one and petal length is the red one. So this was how a k-means clustering has been implemented on a data set. Thank you for watching this video, and thank you for the opportunity given by the Spark Foundation to work as a data analyst intern. Thank you.